and welcome to another terrestrial navigation tutorial. Today we will be going over mid-latitude sailings or middle latitude sailings. Today's problem is based off of Coast Guard questions. It is not a Coast Guard question, but it is in the same format, and we will be using the same equations that you would use in a Coast Guard question. Today's question is: a vessel departs latitude 29 degrees, 20 minutes north, longitude 94 degrees, 49 minutes west, for a latitude of 18 degrees, 00 minutes north, longitude 66 degrees, 37 minutes west. What is the course and distance by mid-latitude sailing? So for this problem, we will set up the equation. So I always like to come and start with my lats and longs. 29 degrees, 20 minutes north. Longitude 94 degrees, 49 minutes west. Latitude 18 degrees, 00 north. Longitude 66 degrees, 37 minutes west. We have two sets of equations we can use for this problem. We can either use the ones on the left or the ones on the right. The ones on the left are for equations that give both latitudes and longitudes. So you have both your starting latitude and longitude and your ending latitude and longitude. For the equations on the right, you are missing your ending latitude and longitude. In this problem, we have both of our latitudes and both of our longitudes, so we'll be using only the first set on the left. To start this, we will be looking for P. D low times cosine of LM. So P equals D low times cosine of LM. So D low is our distance between longitudes. And this is taken from our two longitudes. So you need to have your calculator handy. In order to find D low, will we be adding or subtracting the two longitudes? We will be subtracting them because both of our longitudes are in the same hemisphere. So we have two westerly longitudes, we are subtracting. If we had two easterly hemispheres, or if we had two easterly longitudes, we would also be subtracting. If we had a west and an east, we would add them. So 94 degrees, 49 minutes, minus 66 degrees, 37 minutes, 28 degrees, 12 minutes. And it doesn't matter to put a symbol east or west, this is the distance between them. And we'll do the same and find little l while we're working on these. We'll need little l later in the problem. And we'll also need it to find our middle latitude, which is the LM. So LM stands for middle latitude. So little l is the distance between our latitudes. So it's also known as d-lat, just like d-low, but d-lat. So just like for D low, will we be adding or subtracting the two latitudes? We will be subtracting them. For the same reasoning as why we subtracted the two longitudes. Our two latitudes are in the same hemisphere, which means we will be subtracting them. 29 degrees, 20 minutes minus 18 degrees, 00 minutes. We'll get 11 degrees, 20 minutes. And that is our little L. In order to find our mid-latitude, we will average the two latitudes. This only works if you're in the same hemisphere. So because we're both north, we can average them. So you just take 29 degrees, 20 minutes plus 18 degrees and divide that sum by 2. So that would look like this. (29 degrees, 20 minutes plus 18 degrees, all divided by 2. And that would equal LM. If you don't have the same latitudes, if you don't have the latitudes in the same hemisphere, you'll need to do it a different way. So you'll get little L, and then you have to divide little L by 2. Which is 5 degrees, 40 minutes. And then you'll add this to the lesser then you will so the next step would be to find whether you will be adding this value to the first lat or the second lat. So in order to get a middle latitude, so a latitude between our first lat and second lat, we should either add 5 degrees, 40 minutes to 18 degrees, or we can subtract 5 degrees, 40 minutes from 29:20. You'll get the same answer either way. I prefer to add. So 18 degrees plus 5 degrees, 40 minutes equals 23 degrees, 40 minutes. And this would be the same as if you had taken the average in this particular case. So now we can find P. So P equals our D low, 28 degrees, 12 minutes, times cosine of our middle latitude, which is 23 degrees, 40 minutes. So you'll need to type that into the calculator. To 8 degrees, 12 minutes, times cosine, and have your parenthesis open. It should automatically do this for most calculators. 23 degrees, 40 minutes, and close that parenthesis. It's very important to do that. P equals 25 degrees, 49 minutes, 41.79 seconds. It's important to keep this into your calculator. You should not round until the very end of the problem. So we'll go into the next problem listed, which is tangent of C equals P over L. So we already have all that information. Tangent of C equals our 25 degrees, 49 minutes, 31.79 seconds, over L, which was 11 degrees, 20 minutes. So you can keep this into your calculator, keep the p-value into the calculator. So you'll do inverse of tangent. It's typically like shift tangent, or sometimes it's located right above tangent in small writing, or sometimes even a different button depending on the calculator you have. Mine is a Casio and it's shift tangent, and I'll hit the answer button to put what was already in the calculator, which was this p-value. And I'm keeping the parenthesis open still. Divided by 11 degrees, 20 minutes, and close that parenthesis. It's very important that you do the calculator step correctly. It's the step most people have the most amount of error in. So tangent of C equals 66.3. C equals 66.3. So this is not necessarily your course value. It is actually your course angle. So I like to give myself a little reminder of that by writing a little angle sign next to it. So you have to do at this point in the problem, does this make sense step? So we'll draw our little cross that represents our world map. We are starting in the northwestern hemisphere. So I'll put a dot up here to symbolize that. And then our latitude and longitude both change, but we're still in the northwest. So we have to determine if this 66.3 degrees makes sense based off of our course. So we're at 29 degrees and 94 degrees, our lat and long, and then we're going down to 18 degrees. So that would be right in this area. And we are going further east. So we have a southeasterly course. So our second dot should be over here. I like to draw an arrow in that direction. So I know that our course is actually southeasterly. So 66.3 degrees would give us a northeasterly course. So this value does not make sense for C. So something that most people are not taught in class, I've found, is that C is actually a value that you would put into that. So that would be C plus 0. 0 plus C, 180 minus C. 180 plus C, and 360 minus C. I just So we drew our cross, which symbolizes the world map. So we have our northeast quadrant, northwest, southeast, and southwest quadrants. So we will be focusing on the northwest quadrant. We have our latitude of 29 degrees, 20 minutes, and our longitude of 94 degrees, 49 minutes. And these are our starting longitude, lat and long. These are our starting latitudes and longitudes for the problem. So we can put a dot pretty much anywhere in the northwest quadrant to start. Doesn't really matter if it's accurate. So I'm starting with my first lat and long position. Next, we need to decide where to put our second dot for our final latitude and longitude positions, 18 degrees north and 66 degrees 37 minutes west. So how I decide to put another dot is in reference to the first one. So for our latitudes, 18 degrees is less than 29 degrees. So I know the dot is going to have to go below the 18. It's going to have to go below the 29 degrees, 20 minutes. Staying in that northwest quadrant. And our longitude is 66 degrees, 37 minutes, which is less than 94 degrees, 49 minutes. So it will have to be closer to the prime meridian because it is less than the longitude of the first position. So I would put my dot right here, just to give us an idea of where we are and what direction we're going. And I like to draw an arrow from dot 1 to dot 2 so I know which is which. So our course should be southeasterly. Our course angle is 66 degrees, which is northeasterly. So that doesn't make sense. You need to do one more step to find our true course from our course angle. So this is not often introduced in most classes, but if you're in the northeasterly quadrant, it's 0 plus C. So if we had a northeasterly course based off of our latitude and longitudes that we plotted, then we would just leave it alone. It would be 0 plus our course angle of 66.3. For our southeasterly quadrant, it is 180 minus C. For our southwesterly quadrant, it's 180 plus C. And for our northwesterly quadrant, it is 360 minus C. And this is not based off of where you are in the world. This is based off of what direction. So our course is in this direction, so we will be using the 180 minus C. So 180 minus our course angle of 66.3, and that equals 1 113.7 degrees, and that is our true course. So now that we have our course, we'll go into the last equation, which is D equals L divided by cosine of C. So D is distance equals our little l, which was the distance between latitudes, 11 degrees 20 minutes, divided by cosine of the course angle, 66.3. If you accidentally end up using the course 113.7, it's not a big deal, it'll just change your sign. So instead of getting a positive answer, your answer will be negative. So distance of 11 degrees 20 minutes divided by cosine of 66.3 equals 28.196 and some change. So this doesn't necessarily make sense. Why would we only end up going 28 miles? The thing is, you went 28 degrees. Your answer is still in degrees, so you need to convert that into nautical miles. So how would you do that? So 1 degree equals 60 minutes, and 1 minute equals 1 nautical mile. So saying we traveled 30 minutes is the same as saying you traveled 30 nautical miles as a distance. So in order to get this degrees into minutes, we need to multiply it by 60, which equals 1,692.4 nautical miles. And finally, now at the end, you can round, and this is your final distance that you would have traveled. Next, we'll do a problem that has the starting latitude and longitude, but not the final latitude and longitude. Stay tuned for the second part of this video to learn how to do that. This is the next problem we will be working on. We will be using the equations from the right-hand side of the list that was provided to you at the beginning of the video. These formulas are little l equals d times cosine of c, p equals d times sine of c, and d low equals p divided by cosine of lm. A vessel steams 1,234 nautical miles on a course of 300 degrees true from latitude 8 degrees 59 minutes north, longitude 79 degrees 31 minutes west. What will be your new latitude and longitude by middle latitude sailing? So we'll be using the two highlighted things first, so the nautical miles and the 300 degrees true. We'll start with our lat, just like we did at the beginning, so latitude 08 degrees 59 minutes north, longitude 079 degrees 31 minutes west.
So just like in the previous problem, go ahead and draw your cross, which represents the world map. and we are working in the northwest because our latitude is north and our longitude is west. So you can put a dot anywhere in that northwest quadrant. It doesn't really matter at this point in time. Then you'll take the 300 degrees true and start at the dot and go towards the northwest because 300 degrees is northwesterly course. This will give you a mental model to picture when you're working on the problem. Then we'll go straight into our first formula, which is little l equals d times cosine of c. Little l is our distance between our latitudes. So d is 1, 2, 3, 4 times cosine of c, which is 300 degrees. You'll need to type it into the calculator. 1, 2, 3, 4 times cosine parentheses 300 parentheses. And this will equal 617. The next step is to convert the 617 nautical miles to degrees. So what would you have to do that? You will either have to multiply or divide it. We will be dividing it because 1 nautical mile is the same as 1 minute of latitude. And there are 60 minutes of latitude in 1 degree. So in order to convert nautical miles to degrees, you'll need to divide by 60. You can keep the 617 in your calculator and just hit divide by 60 to type it in. This equals 10 degrees 17 minutes. And that is your little L, which you can go ahead and write at the top if you want to, underneath your latitudes. But you'll need to know whether to add or subtract this little L from our first latitude of 8 degrees 59 minutes, which is where the mental model of the course angle comes in. So we have a course of 300. Are we going to add or subtract 10 degrees 17 minutes from our 8 degrees 59 minutes? We will be adding because we're starting at 8 degrees 59 minutes north and we are going further north. So go ahead and type that into your calculator. 10 degrees 17 minutes plus 8 degrees 59 minutes, which equals 19 degrees 16 minutes. That is your final latitude, so go ahead and write it up with your lats and longs. And will this be north or south? It'll be north because we started in the north and we went further north. So don't forget your labels, they are very important. Then we can go on to our next equation. P equals D times sine of C. So we'll use the same exact information as the last equation, except instead of cosine of C, we're using sine of C. P equals 1,234 times sine of C, which is 300. Plug that into your calculator. 1,234 times sine parentheses 300 parentheses. The answer should be negative 1,068.67 and change. The negative doesn't have any consequence on the actual problem. It is just how sine, cosines, and tangents work. You can either multiply by -1 or leave it there and ignore it for the rest of the problem. It won't impact anything. You did the problem correctly. It means instead of using the coarse angle, you use the coarse. Now that we have P, we can move on to our next equation, which is d low equals P divided by cosine of LM, which is our middle latitude. We are still missing what LM actually is, so we'll need to find that. And that is averaging 08 degrees 59 minutes and 19 degrees 16 minutes. So you'll add those two latitudes together and then divide them by 2. This will get you your middle latitude, which equals 14 degrees 7 minutes 30 seconds, and that is your final LM value. So you can plug that in for LM. So D low equals P, which is 1068.67 and change. And you need to have that full number left in your calculator from when you did the last problem. So you may have to retype P equals 1234 times sine of 300 in order to re-get that into your calculator. And then you'll divide that by cosine of 14 degrees 7 minutes and 30 seconds. You need all of it, no rounding, or it will take your answer off by 1 or 2 nautical miles and will give you the wrong information. This equals 1101.99. This is in nautical miles. Still, you will need to convert it into degrees. What is the best way to do that? You can either divide or multiply by 60, because remember, 1 degree is 60 minutes and 1 nautical mile is 1 minute. Because we're going from nautical miles to minutes, we are going to divide by 60. And this equals 18 degrees, 21 minutes, 59.61 seconds. This is your D low, so it's your distance between your two longitudes, and you will use this number to either add it or subtract it from your initial longitude, 079 degrees, 31 minutes, and 00 seconds, which I put there as a placeholder so I don't confuse my values when I am adding or subtracting. Will we add or subtract this number? We will be adding this value because we started in the west and are going further west based off of our 300 degrees of our course. So 79 degrees, 31 minutes, 0 seconds, plus 18 degrees, 21 minutes, 59.61 seconds, equals 97 degrees, 52 minutes, 59.61 seconds. And this is our final longitude, so we can round this at the end. So 97 degrees, 53 minutes, and 0 seconds. For the most part, you won't be using seconds a ton in these larger problems. And when you do, it will be decimals of a minute. So 6 seconds equals 0.1 minutes, and that's how it will be written most of the time. And I'm just at the top writing in all of my information so it's in one place where I can find it all if I'm going back to this problem to look at it later on. So I have both of my Latin longs for our final answer and our little L and our D low. This is the end of the terrestrial navigation video tutoring middle latitudes or mid-lat sailings. Please leave a like and comment any questions down below. Thanks for watching.